Hello, everyone. Hello, hello.
Hello,
Hello.
Professor. Morning.
Good morning. Today we are gonna start our Lab 2 Part B. We had in our last few lectures the state machine, and we saw two types: Moore state machine and Mealy state machine. For a Moore state machine, the output depends on the state. That's why I have here each state. Beneath the state number, I can see the output value.
Professor, are you trying to share your screen? Because we don't see it.
Oh, sorry. In the Moore machine, the output is beneath the state number, and it depends on the state. It is independent of the input. The input is just to move me from one state to the next. And we had the example, the state, the next state part, and the output part. And as you can see, for each state, I have a certain output. For a Moore Mealy machine, as you can see, the input will affect the output. So the output here depends on the state I am at and the input given. So those will determine what will be the output. That's why the next state, it is the same as the one before. But the main difference will be in the output format. As you can see, the process depends on the state, not only the state, but also X. So here, I rely on the state and X to determine the output. Output Y will depend on the state and X. And moving from one state to the other, it depends on the clock, mainly the clock, rising edge. That's why in the process of the next state, I used clock. Of course, if I use reset also, this means that the reset is a synchronous reset. It doesn't depend on the clock. Whenever it is there, it will reset everything.
Professor, I have kind of a basic question.
Yes.
I know we've been doing this for a little bit now, but let's say in this in a process where you're basically writing your if statements and all the conditions, since you defined the process clock and reset, and you wrote if reset equals 1 first, and then afterwards it's else if rising edge of the clock, does that determine, sorry, is that like a hierarchy that it's asynchronous now because a reset comes before the clock? Is that how that works? Like it depends on which one you write first?
Part of it, yes, of course. If I put here reset before, and of course, you can see here the reset, when it comes, I didn't say anything about the clock at all.
Right. So it's asynchronous.
Yes.
Okay, perfect. But if you were to put the rising edge first, For example,
I
let's say
have
you
to
wrote,
check for the rising edge, then check for reset.
okay, perfect.
Okay.
Okay, thank you.
Would you please open lab 2B? Lab 2B.
We can only see the top little bit of it.
No, you can open yours. You have yours on your.
I have opened mine
it is-
already.
Okay.
I was just
Use
telling
it.
you what we could see on yours.
No. You are not. You don't have to see mine. It is yours, and I want you to look at it and start thinking about how you can use the state machine to implement this. I will even stop sharing. Please start thinking about how you may tackle this problem. Anyone may share the screen and discuss his thoughts with the rest of the group.
Can you hear me? Group.
Yes.
So I did my library and stuff, and I have a clock, a user reset, a dip switch, and a state out. But for my signals, which are the internal, I have counter, state, and next state. Does that seem right to you? Is that all I need? It seems like all I've needed so far when I'm writing it. And the counter needs 4 digits because it goes up to what, 13 or something? Yeah, the count goes up to 13 before it pops out.
Is there anyone who wanna share his ideas or her ideas?
I have a question. So would we just only use 2 bits for the full encoding instead of like 3 or 4?
How many states do you have?
4.
So if you have 4 states, how many digits?
Okay, so just 2.
Yep,
Thank you.
thank you.
I can share mine.
Okay,
Let's see. So I have
no,
this.
I don't need to see the program at this time. Please close this.
Okay.
If you wanna share, I wanna see something on a piece of paper, like your translation of this state machine. Hello, Chad.
Yes, Professor.
Is this a melee or a more?
I'm trying to do it with the melee set, or no, I guess it would be the the melee, because the input should affect the output.
What is the output?
The output relates to what state it's in. State 1, 2, and 3 will all have a different data output.
No, you tell me. Can anyone share with us this discussion?
I think I have an idea.
Okay, go ahead.
All right, let me just share my screen. Screen. All right, can you see my screen?
No,
Let's see, allow access to all photos. So how can you see that?
yes.
So I think it's gonna be a melee, and it's gonna have a clock, reset, input, and output. So I kind of wrote this. It's gonna have, like, the
Again,
input.
this is 1 or 2 steps behind what we are asking. We are trying to understand what is the system first.
Oh,
What
all right.
is the output of this system?
Would be
Oh,
a
you're trying to
0.
get the output.
Pardon me?
You're trying to get the output.
Do we have something called output of this system?
Well, I think the output was supposed to be that clock, wasn't it?
1
the
speaks at a
counter.
time.
I believe our output should just be the 2-bit state that we're
The
in.
state. Okay. Because the problem statement didn't say, I will have this LED as output. I'm not going to have this motor as output. It didn't state anything. So I don't have an output. That is how I visualize it. Can you see any output? Hello, Jose.
Yes.
Can you see output? Is there any output stated over here in that problem?
In the program, if I can see output.
In the list, in the statement of the problem statement, the assignment.
Right, I'm looking at it right now on my laptop.
Okay.
So 5, 9, 13.
Samuel? Samuel? Hello, Paige? Paige,
Hello?
have you read the assignment?
I have.
Can you see the output? Can you see any output?
The lab assignment?
Yes, the lab assignment. That's what we are doing today.
Yes. Wait, what are you asking?
What is the output of this system?
When it reaches 15 seconds, it's gonna go back to the state 0. Is that what you mean?
I mean, it stated I have 2 dip switches and I have, those are the input. What is the output?
The state it's in?
The state itself.
Okay,
But I
sorry
don't
about that.
have-
I wasn't quite sure.
I don't have a physical output.
Right.
Light emitting diode, this is a physical output. A motor starting, this is a physical output. Do I have anything like that in this statement, in the problem statement?
No.
So you are saying there is no output of this state machine except going from one state to the other.
Yes.
What do you think, Vitaly?
Well, since it's on an FPGA board and we do have LEDs, I feel like we could incorporate an output.
I am not asking you to invent a new problem. I'm asking
well,
you
just
to
based on
tell
the
me
circuit.
the problem statement.
Yeah, based on the problem statement, there is no output. It's all
Oh,
internal.
okay. Of course, as you can see, this is a problem not related to a very real system. In real system, there must be some output. But for this one, there is no output as far as I can see it. Back to Jose.
Yeah,
Do you agree there is no output?
yeah, there's no output. I see it.
Okay.
Oh, yeah.
Are
there's
you
no-
ready for my next question?
Maybe.
Oh, why maybe?
I don't know. I'm just trying to understand like the state machine design and all of its functions.
Okay. What are your plans for this weekend?
It's Halloween, so
Halloween. Yep.
yeah.
Okay. So what are you gonna do in this Halloween?
I don't know. Maybe. Well, there's a volleyball game tonight, so I'll go to that and.
Yes,
I don't
Jose.
Okay, enjoy it.
Thank
So
you.
you are ready for the next question.
Sure.
Our first thing we thought about, it was, do we have output? He said no output.
Right.
Now, you tell me, are we gonna design a Mealy machine or a Moore machine?
Millie.
Please open my lecture notes, the PowerPoint, and tell me.
Let me see. So, week 4. So the milli state machine, we have a clock reset X and Y. Which is, I mean, I'm seeing it right here. Here, let me see, see if I can share my screen. Let's see. So not that. How do I change that? There. So that's the milli state machine.
What difference between milli and more?
Well, milli and more. This is the more. So difference between this more state machine and the milli right over here. I mean, for me, it looks very similar to each other, but the input is X10 and output's Y10. So X10, Y0. Clock reset XY. Clock reset XY. Clock reset XY. Clock reset XY.
Cameron?
Yes.
Hello, Cameron?
Yes, Professor.
What difference between milli and more?
A milli machine depends on the output and a more machine does not depend on the output.
No. Hello, Jim?
Yes, sir.
What difference between milli and more?
More just uses the clock cycle and goes ahead. Milli uses the clock cycle, but to go to the next state, it also needs some kind of other reference. So you'd have like if X and clock. And so in this particular one, we need the dip switch as well as the clock. So that means we need two pieces of information, not just the clock to go ahead. So I think that means it's milli.
For this more machine,
This is a more machine?
can you see it?
No, because it needs a dip switch.
This, can you see my screen or not?
No,
Just not let me share.
I see you, but not your.
In this machine, this is a more. How do we move from one state to another?
In a more machine, it just depends on the current state.
If I am in state 1, why should I go to S3 or S2? Waiting for your answer.
Based off of the first value of the input pin, 1 or
So
0.
it depends
you'll
on the
go to-
input. It depends on the input. Yes or no?
Yes, it does.
That's true, because there's the dip switch. If it's 1, it goes one way. If it's 0, it goes the other way.
So it depends on the input.
If
Exactly.
it depends on the input, that means it's a milli machine.
This is called more. I'm
You
stating.
said that milli depends.
I am saying here we are speaking about more machine and moving from one state to the other. It depends on X and the current state. This is my current state S1. I can go to S3 or S2 depending on input and where I am. I am at S1. This is S1 here. I can go to next state S2 or S3 depending on X. So moving from one state to the other, write it down, write it down. Moving from one state to the other depends on the current state and the input. Have you all written that down?
Yes.
Page? Hello,
Yes.
Page? Are you still writing?
Yep, I'm writing, moving from one state to the other is current state and input.
Depends on the current state and input.
That's a Mealy.
It is written here more. Do I have to swear? It is written more, more. Here, more. Slide 20. Now, here, the output. What does it depend on? Output Y.
Just your current state.
It depends only on the state. Write it down. Output depends on the current state. And the diagram states that each state has its own output.
Professor, can you repeat that? So the output depends only on the
Current state. Can you see it differently? We are here to discuss. Can you see anything that affects the output other than the state?
No, it seems that just the state affects the output.
Thank you, thank you. What is this machine? What is this machine? Hello?
This is a Mealy statement.
Oh, thank you. Now, what does the next state depend on? Cameron?
The state depends on the input and the present state for the meaning.
We can
So
see
that's-
here, this is state and X. The same as the Moore machine, correct? The Moore machine has the
Yes.
same thing. It depends on where I am and what is the input. That will determine what will be my next state. So my next state, as in Moore machine, it depends on the current state and the input. Hello, Jose? Jose,
Yes, Professor.
have you written that down?
Yes, depends on the current state and input. The Mealy
Okay,
station.
so it is like Moore machine.
Right.
Now, look at this output. What does it depend on?
On the input
And,
in output.
no, this is the output. I'm looking for the output. Output will not depend on output.
That's right. So input and
Look at the program.
Logic. Non-clock.
The program to the right. Have you read it? What is the first line?
Forming logic state X.
Yes. And what is the case statement?
The case statement 0, 0, 0.
The third line, line 88. What does it say?
Case state.
Do you know what is case statement is?
No, I'll be honest, I don't.
We are moving from one choice to the other, like if statement, according to the value of state.
Got
When
it.
I say when 0, 0, 0,
Uh-huh.
that means state should be 0, 0. When I say when 0, 0, 1, state should be 0, 0, 1.
Got it. Moving from one case to another.
And each time I am getting Y the output. So the Y output depends on what?
Okay, what I put depends on X.
And X, yes, because there is if statement here. It can change the output. What else?
So it depends on the case of the state.
It depends on the state, yes. As you can see in the diagram here, I am in this present state. I can have output 0, 1, depending on the input. And from the same state, I can have output 1, 0, depending on the input. So in this Mealy machine, output depends on state and input. Have you written that down, Paige?
Yes, I have.
So what is the difference between Mealy and Moore?
You know, Professor, I couldn't tell you.
You have written it.
Yes, I have.
Read what you have written in both.
Oh, the current state. One of them's dependent on the, so Moore is current state and Mealy is input and state. So I still don't know.
Aren't those the same?
Huh?
The next state in Mealy machine and the next state in Moore machine, are those the same?
No,
Why? What did you write?
I didn't write that much.
You told me, I asked you, have you written? You said, yes, yes, I did.
And I thought I did, but they look awfully the same. The more
Okay,
and what I wrote down.
this part, they are the same. Have you
Okay.
written the output? What does it depend on in Mealy and Moore?
Input and state,
And in Moore, what does it depend on?
current state and input.
So, does it say input?
Yes, mine does. That may be wrong. So is Moore just dependent on the current state?
Yes.
Yes.
Okay. Then the output on the Moore is only dependent on the current state, and the Mealy is dependent on input and the current state.
Excellent.
Awesome.
Excellent. Hello, Jim.
Yes, sir.
Do you know the difference between Mealy and Moore?
I think so, but since the one we're working on, you didn't ask for output at all. And it really
This is
Mealy or
another
Moore.
step. This is another step. Wait now. Do you
Okay,
know the difference between Mealy and Moore?
yes.
Thank you.
In a Moore machine, the output only depends on the state you're in. In
Yes.
a Mealy machine, the output you get depends not only on the state, but the input value.
Excellent. Excellent. Please don't take material from me without understanding it. That is a very terrible mistake. Don't move from one step to the other. Right now, I'm surprised that, or I thought that you do understand what is going on. You made the two programs and the two programs are running. And now we need to explain again and again what the difference between meal and more. So please do not just jump from one to the other, just running a program. It is not the objective. Now you are stuck in this lab because it is different than the one you copied and pasted. So please don't move from a program to the other without understanding what is going on. Now, as we understand, of course, don't take just statements without understanding what does it mean, or write a program without understanding what does it mean. Case statement. We had this case statement and we wrote it and we discussed it. If you don't understand it, stop and don't program. Don't just copy and paste. Now we go to our problem. First, we decided that there is no output. Now, Chad,
Yes, Professor.
will it be mealy or more?
I don't think it matters because there wouldn't be an output, so therefore it wouldn't matter.
At least to be satisfied, which is simpler.
The more.
Okay. Both of them will not have the output part. Yes.
Right.
Okay. We can go with the more, and you have the program that you wrote for more, and you need to update it according to this. And it is not going to be easy. Remember, it is not going to be easy. So you should give it time. Any questions? Hello?
Is this still due on Monday?
Yes,
Okay,
because you have the following Monday, you have a bigger project. You have the vending machine homework.
Wait, Professor, I think you made an update though that this lab report 2 is due on November 6th.
I have just updated it. Yes, thank you.
Okay, thank you then.
so in 3 days, not the 6th.
No, as whatever I say, just rely on what is written on your canvas. What do you see on canvas? Would you please check that?
It shows it due on the 6th.
Okay, due on the 6th.
You are very kind, Professor. Thank you.
Thank you all.
I have a question regarding the lab.
Yes,
So on the lab report, would you want lab 2A as well as lab 2B?
yes, because you have only one slot to upload.
Okay, thank you.
So I need one PDF file.
Okay,
One PDF file that shows the program code and the output, the waveforms for each one.
okay, that makes sense.
Thank you, Professor.
Please try to think about the vending machine, the homework of this topic. Okay? Thank you
Will do.
all. Have a great weekend. Bye-bye.
Take care, Professor. Thank you.
Thank you.
Thank
Who's
you,
bringing,
Professor. Have a great day and
You
weekend.
who's
too.
bringing
Bye-bye.
candy for Halloween?
Happy Halloween.
Yep.
Professor, I have a question actually.
Go ahead.
What are you gonna dress up for Halloween? What's your costume?
Oh, yes, yes. Here in Phoenix, at this university, they had a contest for engineering faculty on how to dress. for
Okay.
Halloween. Okay.
Well, tell me you won. Tell me you won. Tom Cruise.
Yes.
I'll never forget, Professor.
Okay. Thank you all.
That wouldn't be
Bye-bye.
fair because you wouldn't have to dress up at all.
Yep. Okay. Enjoy the Halloween. Bye-bye.
Bye-bye.